Hi, my name is Karl. I'm a third-year doctoral candidate with the Institut Polytechnique de Paris. I joined the EconophysiX Lab in 2021 after doing my master's in financial economics, and I also have 2 bachelor degrees, one in econometrics and one in economics. So I came to econophysics through the field of complex systems, and what appealed to me about econophysics is the interdisciplinary approach. So it gives me a certain freedom to think about problems from multiple, sometimes unconventional angles. And as a researcher in this area, I've been able to explore alternative economic frameworks and understand complex systems from a physics perspective. In particular, I find that physicists have a variety of tools to understand how microinteractions can lead into macro phenomena, and this has been really useful in my own research. So I'm working on scenario generation with agent-based models to understand and support the knowledge base for economic policymaking in response to climate change and the associated energy transitions. So specifically, economists and other researchers have built models which are called integrated assessment models that attempt to combine energy systems, the environment, and economic aspects all into one model. I study a particular class of these models that are agent-based, which means that they create a large simulation of a lot of micro-agents, for instance, individual firms, households, or financial institutions. In doing so, we can observe how macroeconomic phenomena, for instance, growth and cycles of GDP, emerge from microinteractions. But one can also study distributional dynamics for these agents, such as wealth or income inequalities. And it's clear that these models have a lot of potential, but at the same time, it's hard to disentangle the mechanics of these models and understand how specific parameters can affect different outcomes. And so the main contribution of my research is to develop a methodology, including an algorithm, to explore these agent-based models. In particular, we aim to be able to identify the different phases of a model that represent qualitatively different dynamics. For instance, stable full employment versus cyclical high unemployment in an automatic way. And then understand which parameters or parameter combinations lead to transitions between these phases.